So in this video, we're going to use the formula we previously developed for finding derivatives of the constant multiples of a function. So in this case, it says find the derivatives of f of x equals 5 root 3 of x squared and pi over 2 third root of t to the fifth. So we're going to take two derivatives. So we'll start with this guy here. So we've got f of x equaling 5 times the third root of x squared. And then what we want to recognize is that this radical form here can be rewritten using a rational exponent. So this guy right here is the same as x to the 2/3 power. And so I have a function that we can use the power rule for with the x to the 2/3, and I have the constant multiple of that function. So to take the derivative, f prime of x, I'm going to take d dx of 5 times x to the 2/3. And the constant multiple rule that we have up here says if we're taking the derivative of a constant times a function, we can just take the constant times the derivative of the function. So this is going to be the same as the constant 5 factored out, kind of informally factored, you can say factored out. So 5 times d dx of x to the 2/3. And this is of the form x to the a, so I can use the power rule. So this is going to be 5 times the derivative of x to the 2/3 is going to be bring the 2/3 down into the coefficient position times x to the subtract 1 from 2/3. So 2/3 minus 1 is negative 1/3. And then this can be simplified a little bit. 5 times 2/3 is 10/3. X to the negative 1/3. So this one, I'm going to go ahead and rewrite it. G of t equals pi over 2 times the third root of t to the 5th power. And this can be rewritten as the constant pi over 2 times 1 over the cube root of 3 applied to t to the 5th can be rewritten as t to the 5/3. So I can rewrite this using a rational exponent. So t to the 5/3 power. And then I want to recognize that I can get this into the form t to the a by bringing the t up into the numerator position. And instead of 5/3, writing negative 5/3. So now I have something that has something I can apply the power rule to, with a equaling the negative 5/3. So if I want to find the derivative g prime of t, I'm going to take d dt, because now my variable is t instead of x, of pi over 2 times t to the negative 5/3. But I have the constant multiple of t to the negative 5/3. So the d dt of the constant multiple will be the same as the constant multiple times d dt, because my variable is t, d dt of t to the negative 5/3. And let's walk this up here. So g prime of t equals, it's going to be pi over 2 times, bring the exponent down using the power rule, bring the exponent negative 5/3 down into the coefficient position, and then subtract 1 from negative 5/3. So negative 5/3 minus 1 is going to be negative 8/3 equals, I can simplify things a little bit here. I have negative 5 times pi is negative 5 pi over 2 times 3 is 6 times t to the negative 8/3 is my final result.